Okay, good morning. This is our week 12. I'm going to carry on with 3DMohr circle. Okay, then we're going to go into a new topic, design analysis of beams. So 3DMohr circle, we're going to do two examples over here. We have not finished the last one yet. Okay, then we're going to go into design analysis of beams, and we're going to include combined loading over here. Later on, I will explain what do we mean by we're going to combine loading. Okay, so I have posted some figures on Avenue to Learn. Okay, so you go to Avenue to Learn to download those figures that I will be using. Okay, so last week we are still dealing with this problem over here. Okay, we're still dealing with this problem. We have not finished yet, and we're going to continue on this problem. Okay, so let me help you recall what this problem is. Give me a minute. Okay, so this is the example. We're going to continue. So it is a 3DMohr circle problem, right? We are given that we have a stress X of 14 KSI, a shear stress in the XY plane or in the XY direction at 8 KSI, 8 KSI. We were tasked to find stress Y. Okay, so we were tasked to find two values of stress Y. Okay, and there's a condition that we have to meet. The condition that we have to meet is tau max must be equal to 10 psi. So that is the condition that we have to meet. So last week, where we finished off, I show you a situation where the solution is the solution is not possible. Okay, last week where we finish off, we realized that we pick y1, right, to be equal to 26 KSI. Okay, and it's not valid. Why it is not valid is because our operating limits of our material is in this blue highlighted area that I'm drawing now. Okay, it's in this blue highlighted area. If the circle, I repeat again, if the circle is bigger than the blue highlighted area, the material will yield. Okay, the material will yield. So this is not a possible solution. I repeat again, this is not a possible solution. Okay, so next we have to try other option to find what is the correct solution. What are the possible solutions? So for this case, what we did is we calculate our stress average, okay, to be equal to 20 KSI. Okay. Then we're going to pick a different stress average. Okay. So I'm going to start from there. So I'm going to start constructing a Mohr circle again. Okay. I'm going to start I'm going to start constructing Mohr circle again. Computer not working, or is it the user? Usually it's the user, not the computer. Okay, I'm going to string this down. We have seen the problem. Okay. So we are going to draw Mohr circle. Okay, so I'm going to that the yield is 20. So I'm going to start from, I'm going to draw the whole thing again, okay? Just to elaborate what I was talking about earlier. 18, 16, 12, 10, 8, 6, 4, 2, 0, 2, 4, 6, 8, 10, 12, 14, 16. Missing 14. Come on, Eugene. 14, 16, 18, 20. This is normal stress. Okay. Then we have our shearing stress. So shearing stress, element rotate clockwise at the top, element rotate anti-clockwise at the bottom. 2, 4, 6, 8, 10, 12, and minus 2, minus 4, minus 6, minus 8, minus 10, and minus 12. And I'm going to sketch our limits. Okay, so the circle cannot be bigger than this rectangle. I'm going to draw. Okay, it cannot be bigger than this. So in terms of shear, this is our 10 and minus 10. Normal stress is 20 and minus 20. Okay. And I'll explain to you why later, why 10 is understandable, because that is your tau max. Why is it 20? Okay, I will explain to you later why is it 20. Okay. Now, then we are going to have, so we have a normal stress of 14 given. Okay, so given, and our shearing stress from our diagram, it is what? It is, shearing stress is what? I forgot. I'm going to zoom in. You know, sometimes the pen don't behave or the user. Go on, there's something wrong with my computer today. Something is not behaving. Something is just not like, go on. Okay. So the shear is 8. Okay. The shear is 8. And my 14 line is not straight. Interesting. I think I drew too long. That's why I did not like it. Okay. 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 Now it will behave. So our shear is 8. Our normal stress is 14. So that's why it's given. Okay. So let me sketch out the element. Okay. So we know that we have 14 down here. We have 8. Stress Y is what we don't know. Okay. So if we draw our, if I were to draw transformation, X, Y, and Z. This is our point X, point Y, and this is our Z. Okay. So we know X is 14, right? And rotate, the element will rotate anti-clockwise. So this is our point X. Okay. So the next one we're going to calculate, the last time we tried the stress average one is on the Eugene, come on, is on the right hand side of point X, right? So now we are going to do the stress average, the left of point X, not to the right. Okay. So we are going to calculate stress average. Okay. So I'm going to calculate over here. So we are going to calculate stress average 2, right? So stress average 2 is equal to 10 squared minus by 8 squared. Okay, so not stress, so it's equal to, sorry, it's equal to 14 minus by square root of 10 squared minus by 8 squared. So this will be equal to 14, so 10 squared minus 8 squared, square root 6, 14 minus 6 is equal to 8. And I'll tell you why we do that, okay? We now know that our stress average is at 8. Okay? We now know that the stress average is at 8. So I'm going to draw a green line to indicate the stress average is at 8. And this is our point, and this is our point O. And why that is, so what we just found, that this distance over here, wrong. This distance or this from here to here is our stress average. So why is that? Okay, because we know that this height over here, right, is equal to 8. Okay, this height over here is equal to 8. And we are also aware that the radius, okay, to the stress average over here, this distance here, okay, the distance from here to, we use a different color, pardon me. The distance from here to here this distance over here is equal to 10. Okay. So the distance from here to here now, rather than here to here, do apologize, okay. So we just found the distance from here to here, right? So this distance is square root of 10 squared minus by 8 squared, okay, for that simple reason. Okay. So let me write out how I get 14 or 8. So this is equal to 14 minus 6, and this is 8 KSI. Okay, so that is how we get our stress average 2. Okay, our stress average 2. So now we know where the stress average is. We can extend this line, and when it intersect the 8 KSI, okay, this is where we have our Y1.
Eugene.
Yes. Hey, Opara, how come you're not here?
Long story, but I'm in Toronto. Like, it's very hard for me to drive down sometimes.
Okay, it's okay.
So how do we know right away that the diagonal distance is 10? Is it just by knowing that tau max is 10? Like
Yeah,
how?
that's the radius, right?
Oh, right, I see that.
Yeah,
Okay.
all right. That's the radius, right?
How come you drew it from point?
Huh?
Wait, how come you drew it from point X if tau max will be from the red line at the top? Because tau max is from the top of
X
the
to
circle.
point O is the radius.
Okay.
Okay. I already miss you already, you know. Okay.
Okay.
So that is our point 1.